First one, random sample of 100 people that would better estimate the proportion of all registered voters in the district who would support improvements to the high school football field should be drawn from registered voters in the district. So you got to take a sample of 100 people in the neighborhood who want to improve the high school football field, right? Because it's the money from the taxes that are going to be used. So the registered voters, and that includes uh, the people in the neighborhood. So where would you find a good sample that would represent everybody in the district? Well, if you were to take 100 people, would you take 100 people for a football game? Would they represent a random sample? 100 people from the supermarket, 100 people from a school fundraiser, or 100 people from a high school band concert? Well, I think you will agree with me that if you took 100 people from a football game, that would be biased, right? They would most likely say, hey, we support improvements. Okay. I'm going to skip the supermarket for a second. School fundraiser, again, same thing, most likely, because the improvement to the high school football field um, is an improvement to the whole school environment. The people who are um, sampled from a school fundraiser will most likely also be biased because they would support improvements. Likewise, high school band concert, but I mean, the high school band concert, I mean, they might go the other way and say, no, I don't want support improvement to the high school football field because I want improvements to, I don't know, getting new instruments. So they could be biased, but biased to the other side, or they could disapprove the improvements, but nevertheless, it's still biased. So the only group that actually makes sense, because in the supermarket, you're going to have shoppers, right, who are from the district, okay, who may support school improvements and who may not support school improvements to the football field. So I think that the only group that is random or more representative of everybody in the district. Likewise, the second question here, Chuck's trucking company has decided to initiate an Employee of the Month program. To determine the recipient or the winner of the Employee of the Month program, they put the following sign on their back of their trucks. The driver who receives the highest number of positive comments will win. Again, think about you putting this behind your truck. You can ask your family and friends to call, right? Most likely, people who want their opinion to be heard will only be calling. It's not everybody who sees you driving that's going to be calling, right? People who have a favorable or unfavorable opinion of your driving will be calling. So that it's not really random. So this one, right, explains that part. Three students are chosen at random. Find the probability that all three were born on Wednesday. So the probability the first student was born on Wednesday is we want probability of what is this? Wednesday and Wednesday and Wednesday. Probability the first student was born on a Sunday is 1 out of 7. Right? Second is 1 out of 7, and third is out of 7. So what is that? 7 times 7 times 7, 1, 3. So 1. Probably that all three students were born on a Wednesday, is 1 out of 340. Are the following events independent? You roll a 3 and a 4, yes, because you have probability of rolling a 3 and then probability of 4. So the probability of rolling a 3 is 1 out of 6. And because it's independent, right, the next time, the second roll, when you're rolling a 4, does the total change? Right? Does the number of faces change? Do you have one less? Can you put the 3 in your pocket and go back to the die and now all of a sudden you have one less number? No. Right? The first row does not affect the second row. So it's 1 out of 6 times 1 out of 6. So it's independent. Smith family decided to have their new house built. They found there were 60 different choices involving location, style, and color. If they had their choice of 2 locations and 5 styles, how many choices of color did they have? Okay, so this is going backwards. So 60 different choices involving location. So location, the number of choices they had in location times the number of choices they had in style times the number of choices they had in color gave you 60, right? So from location they could choose 2, and that's given to us. From styles they could choose 5. From colors, how many choices do they have? Well, 2 times 5 is 10, and then 10 times what number is 60? That would be 6. So for color, they were given 6 options, 6 different colors. Right, so the total number of different choices that they had would have been 60. Okay. You toss a coin 30 times and get 12 heads. The experimental probability of getting heads is, and again, experimental. So the probability of getting heads, theoretically, right, without you performing any experiment, is a half. Now, let me write theoretical on top. The probability of getting heads in this experiment, right, experimental, according to the experiment, probability of getting heads, well, you got 12 of them out of 30. We can simplify. Divide by 6, we get 2. Divide by 6, the probability of getting heads in the experiment was 2 out of 5. Number cube is rolled 330 times, and the results recorded as follows. There were 55 ones, 62s, 49 threes, 58 fours, 57 fives, and 51 sixes. What is the experimental probability, again, experimental, of rolling a number greater than 4? Greater than 4 was 5 or 6. So if you rolled a 5 or 6, that's what we want. Well, for 5, you had 57. For 6s, you had 51. So in this experiment, the 5 or 6 came out 108 times combined out of, well, we know the total already, out of 330. And you're more than welcome to simplify, and I will do that because I have a calculator. And it's going to be 18 out of 55. Simplified. The accompanying Venn diagram, Venn diagram problem, shows the results of a survey asking 100 people if they get the news by reading newspapers or by watching television. So we have, and here is, you have to know how to read a Venn diagram. 15 people, and they get their news only from newspaper. 25 get it from television only. 40 of them get it from both media, newspaper and television. And 20 don't get it from television or newspaper. Okay. So what's the probability that a person selected at random from this survey does not claim television as a source of getting the news? So they don't get their news from the television. So they don't get the news from the television would be anybody, okay, that is here. Does not claim television as a source of getting news. Well, we also have to include these people here because they also don't get their news from the television, right? Maybe they get it from their phones. So the 2 groups that we have to consider are these guys and these guys. So we have 15 and 20, which is 35 out of 100. We already know. We divide that by 5, we get 7 out of 20. The probability of not television to get it from anywhere else but television, it's 7 out of 20. So if you were to pull one of these people, you know, all their names were in the hat, and you want to pull one of them, the probability of you selecting somebody who does not get their news from television would be 7 out of 20, which would be these guys and these guys combined. Solve the equation. Okay, so again, this is coming up, and the more you're used to this, it says solve and check. So you did this in the 6th grade. Well, maybe a simpler version, but you still did it. I know you did it distributed properly. So an equation is an expression, right? The left side, the expression on the left equals the expression on the right. So this says 4 times, parentheses, 2 times a number plus 3 equals negative 3. That number minus 1 multiplied by negative 3 and then add up 31. We got to figure out what this is, right? So on the left side, and again, if you want to think about two different sides, we can do this through properly. We get 8a plus 12. There's nothing else to do besides that. On the right side, let me put the equal sign again. Multiply these two. Negative times a positive is a negative. Negative times a negative is a positive. And then we have plus 31. On the left side, again, there's nothing, so I'm just going to rewrite it. On the right side, I can combine some like terms. These two are like terms. Instead of saying 3 plus 31, I can say 34. Right? Now, I have variables on both sides. One of them I want to get rid of. I want to put my variables all on one side and my constants all on the other side. That's what I'm basically doing. So let me shift this 3a to the other side. Right, so by subtracting this 3a from this side, so I'm sorry, adding, right, because it's the inverse operation, think about it. Negative 3a plus 3a becomes 0. So that literally goes away. I can put plus 34, which I'm going to erase because we don't really need that 0. So the right side, all we have is plus 34. On the left side, we added 3a, right? Because if we add 3a to one side, we must add 3a to the other side, so we get 11a. And then, don't forget, plus 12. So my equation looks like this now. 11a plus 12 equals 34. So notice that only one side has a variable. Now I have to get rid of the constant here, the plus 12. So I'm going to do subtract minus 12 from the left, which means I subtract minus 12 from the right. That goes away, 11a, and this is 22. Now divide both sides by 11, and we get that a is 2. So it's telling me that if I come back, and here's my check, which none of you will like to do, it says plug this 2 over here and plug this 2 over here. The left side should equal the right side, so let's do that. So 2, instead of, I'm going to leave some room there. I'll change colors. So wherever we see the a, I'm going to replace it with 2. So I'm going to get 2 times 2, right? And then there's a 2 over here. Now it's just simple order of operations, right? Which we all theoretically know how to do. We have 2 plus 2 is 4. Sorry, 2 times 2 is 4. Plus 3 is 7. So we have 7 times 4, right? Let me just. And then 4 times 7 is 28. So on the left side, that whole expression equals 28. I hope to God I get the same thing on the other side. 2 minus 1 is 1, and 1 times negative 3 is negative 3. Plus 31. Negative 3 plus 31 is just simply 28. And look, a is the solution for our equation. Okay, so that's a solving check. Next question. How do you explain to a fourth grade student that a negative times a negative equals a positive? So let's start with something like this. Negative 2 times negative 8. How do you tell that kid who's in the fourth grade that it's 16? Well, let's try something different. Let's use something. I want to use a distributed property. So let's do negative 8 times, and I'll do this. Thinking of an easier way. Negative 2 times, well, if I do that, let me do something else before I get to that point. Let me do this first. Negative 2 2 times negative 8. Let me explain that first, and then we'll get to a negative times a negative. So let's do this one first. Okay, so let's focus on this, a positive times a negative, and then that's going to help us explain a negative times a negative. So that's what we'll do. So how do I explain this? So we got to start with that first. Well, we can do something like this. So before I answer that, I can do this. I can go 2 times 8 plus negative 8. I set that, and then equal to 0. Well, let me put a parenthesis here. 8 plus negative 8 is 0, and 0 times 2 is 0. So this is a true statement right here, right? So that we know that 2 times 8. So, and then let's take a step back. 2 times parentheses 8 plus negative 8 is 0. So I set up an equation that is true. We all know it's true. We can use all of our operations. Then, but I want to use the distributive property here. I want to use the distributive property to help us understand this part. Well, if you do the distributive property and you multiply a positive 2 and a positive 8, you know by now that that's 16, right? You've known that all your life since the moment you learned the times table. That's 2 groups of 8, and then you can obviously 8 plus 8 equals 16. Now, you can also now understand that 2 times negative 8, even if you didn't know what that was before today, well, the only number that we can put in here that will keep this equation true, right, because it has to equal 0. We know 2 positive times 8 positive is 16, and we know that 2 times 8 is 16, but we just don't know that still, that in order to keep that equation true, this has to be negative. So logically speaking, the only acceptable answer for 2 times negative 8 would be negative 16. And we can prove this using the distributive property. Right, so now that we know that 2 times negative 8 is negative 16, I can come back here and put that there. Right, so I use the distributive property to logically understand that 2 times a negative number, it's now negative. Okay. Now, how does that help us with this? Well, because I'm going to do the same thing. So I'm going to take negative 2, and I'm going to multiply by 8, and then I'm going to multiply by negative 8. And then I'm going to create an equation that's true, first of all. Well, first of all, 8 plus negative 8 is 0. And 0 times negative 2 is 0. Right? So again, I'm going to use the same. I'm going to do the same thing that I did on top and use the distributive property. Well, let's do that. 2 times 8, I apologize. Negative 2 times 8, we just talked about it, and we know that's negative 16. Right? And again, to keep this equation true, what's the only answer that I can put in here? So let me put a plus. That I can put in here to keep that equation true, because I'm not changing anything. Right, so a negative 2 times a negative 8, well, if you put negative, that equation is not going to be true. So the only number, and the only other possible choice that you have is that a negative 2 times negative 8 is positive 16. And if you put the positive 16, now you have an equation that is true. Negative 16 plus 16 equals 0. So using something that we know, right, which is the distributive property, we proved that a negative times a negative is a positive. So 2 times negative 8 is 16. Pretty sure they do the distributive property there, right? I hope they do. So there, that's how I would explain it, right? Okay, using your prior knowledge, right, of multiplication, right, a little bit of logic, common sense, right, to say that, hey, for example, when we go back to the first example, well, we know 2 and 8 is 16. Again, we know this equation here is a true equation, right? It's 2 times 8 plus negative 8 is equal to 0. So not changing anything, but just rewriting this equation, right, by doing this tree probably 2 times 8 is 16. And again, going back just in case. and 2 times negative 8, if you didn't know what it was, you could sort of imagine and guess that the only possible answer it would have been negative 16 because you had to keep the equation true. And based on that, we moved on to the next one. So on the next one, right, I needed to prove this. Well, we already proved that a positive times a negative is a negative, and that's how I get negative 2 times 8 equals negative 16. So when you did the second part of the distributive property, right, when you multiply the factor that's outside the parentheses times the second term here of your expression in the parentheses, well, you're now stuck with negative 2 times a negative 8. Well, you know the number 16, and you were stuck between is it negative or positive? Well, in order to keep this equation true, it has to be a positive, right? Because negative 16 plus 16 equals 0. Now, if you decided that it was negative 16, that wouldn't really work. Okay, so that, and this helps us answer this. Okay, we're gonna talk about it again when we come to that part of the unit coming soon, but this is more of a preview for you. Okay, and that's that. Very short video.